And this problem is associated with introductions to trigonometry and studies of degrees and radians. We're going to look at a problem in linear speed. And in this case, I've got a car that is traveling at 65 miles per hour. And we also know that the wheels of the car have a specified radius. The wheels have a radius of 15 inches. And then based on this information, we'd like to know what rate the tires are spinning in revolutions per minute. So we are looking for RPMs, the revolutions per minute. If you look at a text at a problem like this, they're going to give you some formulas. I'll write the formulas down here. I got formula S is equal to R theta, and I've got a formula S over T is equal to R theta over T. But I don't really like these formulas. I wouldn't like to have something else to memorize when I could do it without a formula. So I'm not going to use the formulas. If you want to use a textbook and look at how they use those formulas, you can do that on your own. So I'm going to look at it like this. Essentially, I'm going to have some calculations here, typically multiplying some things. I don't know what yet, but I'm going to multiply some things and end up with a numeric solution. And if I keep track, I'm going to be able to get to the units that I want. So RPM over here, this RPM here, that's not the best way to look at it. I want to look at it as revolutions per minute. That's looking at it as a fraction that I can get to. So what's going to get me there is these calculations, and I'm really interested in the units of the calculations. For instance, I have 65 miles per hour. All right, now look at that. See, I've got hours here in the denominator, and I'm going to be able to get hours converted to minutes, right? And then the miles kind of need to get converted to revolutions. I guess they do need to get converted to revolutions. I don't know if that's the best way of thinking about it, but that's what's going to happen. So let's look at the minutes first, the hours and the minutes. That's really easy, right? There's 1 hour for every 60 minutes. And I'm keeping track of the units here. And we can see that, these hours are going to be canceling with these hours. Or those units of hour are canceling with those, and that's going to leave me with the minutes that I need. So right now, if I multiplied this out, I would end up with 65 over 60 miles per minute. So I'd have miles per minute. Now the next thing that I want to do is I want to get to revolutions, right? I want to multiply by something so that I get revolutions. Now ideally it would be like this. It would be, I would have revolutions per mile. But I'm no closer to getting to revolutions per mile than I am able to just give you an answer of revolutions per minute. So I don't know what the revolutions per mile of these wheels are. But you can see how that would work if I did have that. If I did have that, miles would cancel with miles, and I would be left with revolutions, which is what I need. I need revolutions. So we want to multiply by something that'll take us toward revolutions per mile. So let's go ahead and just look at what we do have. We have another piece of information here, right? I got this 15 inches. And what does that 15 inches have to do with the revolutions that I'm getting? That's the breakthrough there, is to realize that this 15 inches, I can do something with that. So if I've got a wheel that has a radius of 15 inches, I can find out the circumference of that wheel, right? And the circumference is that has something to do with the revolutions. So let's do that. Say that the circumference is equal to 30 pi, right? I'm just using 2 pi r. And I've got r, so 2 pi times 15 is 30 pi. Now what have I done with the circumference there is 30 pi, and that's in inches. I'm going to need to note that at some point. Let me just write it down here. So that's in inches. Well, what do I have with that? I've got a circumference. One circumference is a revolution, right? So I've got inches per revolution now. I know that there are 30 pi inches. I want revolutions in the numerator. See what I was doing there? I was going to mess that up. I was going to go inches, 30 inches per revolution. But I don't want revolutions down here. I don't want revolutions in the denominator. I want revolutions in the numerator. So I'll just do the reciprocal. So let's erase that. And I want to say that I know that I've got 1 revolution per 30 pi inches. All right, so now we're on to something. Because I've got my revolutions here. I've got my minutes here. So the trick is to get the miles, and I need miles and inches to cancel out. And we can do that because I know how many miles or how many inches there are in a mile. Actually, I don't, but we can find out easily enough, right? So I'm going to say, how many inches are there per mile? I can say that. I can figure that out. And then what happens with the units? These miles over on the left cancel with these miles on the right. These inches cancel with these inches. So I need to know how many inches there are in a mile. All right, so I had to look that up, and I got 63,360. 63,360. 63,360. So now I've got all my units working out, and then I just need to do the numbers. And so I've got the revolutions per minute that I need. All the other units are canceling out, and then I just need to do the 65 times 63,360 over 60 over 30 pi. So if I do all that, I get 728.7 revolutions per minute. All right. So it's an important concept or an important idea, this, to be able to do a calculation with unit agreement. And look how valuable it is. I mean, what did I have? I had 65 miles, and I wanted to convert that to inches. So if I have 65 miles, All right? And I want to convert that to inches because I don't know how many inches there are in a mile. Well, what do I know? I know that there's 12 inches per foot. And I know that there's 3 feet per yard. And I know that there's 1,760 yards per mile. So I can do that conversion, even if I didn't look it up. I do have the information that I need. So miles cancels with miles, yards cancels with yards, foot cancels with feet, of course, and then that leaves me with inches. And I'd multiply through there and get the 360 number. So any problem that you have in this category, this rotational velocity sort of category, you can do it by unit agreement. And if you want to use these formulas, you're certainly free to look at how those are applied and to memorize them. But it's not necessary, and I believe it's more useful for other applications and other disciplines to have experience working with the practice of calculation by unit agreement. And that's all.